Hello. So today, I think the goal that I want to do is basically make like a walk-in robot gun. I had made this sort of like prototype a while ago, which is kind of like walk-in robot pants that I thought I would eventually use for this, and the day has finally come. I don't know if this is a thing that you can Google search, but like maybe just search like little polygon locomotion. Yeah, there you go. It'll like pull up this thing from my blog that I wrote about a year ago, which goes into like a breakdown of like how I made this sample code. It's like a two-parter. I've always been meaning to write a third part about sprinting, which hopefully by actually using it, I'll have a reason to actually write that code and then write the third part in this blog series. But basically, here, let me open up a little text file here. I think the checklist of things to do this afternoon is first, like, convert the sample code into an anim node. Anim nodes are like, you can't see that. That's covered up. Anim nodes are like these special objects in the Unreal game engine, which are just like a more efficient way to evaluate animations because it does it on a background thread rather than on the gameplay thread. So if you have lots of these guys walking around, it actually doesn't cost you like any of your like prime CPU real estate that you usually use for gameplay. So that's like a performance thing. And then the second thing is we'll add a new enemy type. We will add a wandering movement mode, which is just, it will kind of, I do this pretty much as my like first step for all enemies, where it'll kind of like wait around somewhere and then walk to another waypoint, and then wait around there and then walk to another waypoint. And then we'll add an aggro strafing mode, which is like once it notices you, maybe it kind of like turns to face you and kind of starts moving a little more evasively. And we're just gonna be using these like robot pants stuff that I wrote way back when, just as our like art for now. But like you can imagine, probably for like a walking gun, what I'll eventually do is add like, copy this model, add a big gun on top of it, maybe add a third like leg in the back that's like a stabilizing leg. But I don't know that we're going to get to that this afternoon. This is just going to be a chill stream. Hopefully by the end of today we'll be walking around and there will be a giant pair of legs also walking around, and it will just kind of be like staring at us and stuff. So cool. Yeah, we're gonna, for starters, it's going to be a little more like code heavy, which doesn't make for the most like visually exciting stream, but like if you have any questions, you can just sound off in the chat, and I'm like happy to like take a break at any time, look at different parts of the game. Oh my goodness, I just realized that the title of this stream is all wrong. Let me fix that. Let's call this Robot Pants. Done. Stream info updated. Great. I'm so good, bad at streaming. Cool. To do. We'll just like scoot this into the corner. Is that like too small to read? This over so you can see this all the time. Answer questions about the game. Cool, that looks good. So, first things first, I need to actually add some new files to my project. Open Explorer. So these files are going to be, I have a bunch of anim node files already, right? Let's see, these should all be, yeah. So we'll just, it's anim node underscore and then the name. So we'll call this anim node underscore loco. Is that good? Then we'll make, in C++, you always have both a header file and a C++ file. And then in Unreal, whenever you're adding an anim node, you have to do both the definition of the anim node in your game source and then your editor source. I guess I've been putting them all in one file, but you need to have like an editor declaration of it as well so that it actually shows up in their animation tool. So now we can come down here. We can say generate project files, beep boop, beep boop, beep boop, beep boop. So now the text editor I'm using to edit code, writer, picks all that stuff up. And then last thing off screen here, let me just add everything to Perforce. That I have an undo point. Okay, great. So now we can say anim node underscore loco, our new files, here they are, they're empty. Oh, it's hot in Los Angeles today. Okay. So if we look at some of our other anim nodes, and let's just say like, what is a simple one that I had? Like the barrel roll one. It's a bunch of boilerplate. I'm just gonna grab it. So for our bone references, we're going to want to have a reference to the hip bone. We're going to want to have foot L, foot R. I'm going to call this F anim node loco. This object, F anim node loco, is subtyping anim node skeletal control base. This is the base type in Unreal for all of their own anim nodes, which basically just like take a pose in and modify it, right? So we're gonna basically just take the like resting pose of the legs in as our input and like modify it, but like you can put this in a pipeline to do anything, like if there's like any authored animations or if you have like an idle loop or like a per limb breathing loop, they can be mixed together. We don't need all these other properties that the thing we copied from needed. And so now we come over here, found include anim node loco.h. Let's grab all these methods. I'm actually going to, let's see, open an Explorer, drag it in here. I'm going to open these real quick in my other text editor, which has a handy dandy multi-edit feature. I can just say find all. Now look at this. I can edit multiple lines at once. So I can comment out this override keyword on all of them. And then we can add our braces. So we can close that, close that, close that. Bada bing, we got all this stuff. Oh, I should have also qualified them all while I had that open. Oh well, too late. I'll just do these one by one. Okay, so here's what all these different methods do. This is all the functionality you need to provide in order to write an anim node in Unreal. So there's initialize. This is just called when the animation blueprint is initialized, if you need to do anything to set some initial values or whatever. You get some like information about the animation blueprint here in this context parameter. There's initialize bone references. This is like you're gonna name a bunch of bones like by name. All of these are gonna become like drop downs that you can pick bone names from. And then what happens here is you need to map those names to actual bones in the hierarchy. And required bones here, this is basically just, it's like a weird Unreal nomenclature thing, but this basically just means like a skeleton, right? Like a hierarchy of bones. We're gonna pick from this set, we're gonna pick the ones that we're actually manipulating. Is valid to evaluate. When it's actually evaluating stuff, it's gonna check this to see like, hey, do I have everything I need to compute a value, or should I just skip this when I'm updating the animation? So like if the bone names that you specified were invalid and you don't know what to do, you can just say, hey, skip me, right? It's like a graceful failure point. Pre-update runs before any of the animation updates. Update internal runs right before you update, and then evaluate is this is the real workhorse method that actually like takes this, you know, component space pose context, which is just the current pose of the character, and then you write out this outbone transforms array, which is an array of results on like which bones you want to modify and what you want their modified value to be. So like in this case, we're going to be adjusting the hips. There's like the main hip, there's the left right hip, the left right knee, the left right feet. So that's like 1, 2, 3, 4, 5, 6, 7 bones we're gonna write into this array. And it's a little persnickety, you have to actually write them like parents before children, or Unreal just crashes. That's fun. So currently I haven't implemented any of them, and I said it's not valid to evaluate. So in principle, this right now this should just do nothing, but that's fine. I want to like first just be able to like create the asset, put this in the asset, make sure it shows up, and then I can start filling in all the bits. And we're going to be copying the code for it from this loco pawn class. This is all the sample code from that blog post. So if you want to understand any of this like blog post stuff, like totally just open it up. You know, you can just go to the post. I break it down line by line, basically. So you can read that. You'll understand all these pieces that I'm grabbing. Mostly, it's just a single tick function, and all of this will just move to update internal. Cool. So now we need to go to star anim graph nodes. So for every single anim node, you also need to have an anim graph node. It's really annoying. I try to keep these in alphabetical order. So H, I, J, K, L, yeah, here. So basically all this is, it's just paired 1-to-1. And instead of having a head look node here, we're going to say this is loco. And then these are various functions that are only used by the animation editor to determine how to present this. And let me go up here real quick. I need to include star and node logo. This is grayed out because apparently it's unnecessary. So let's just sweep that up. So yeah, let's go in here. Let's find head look. Zoop, zoop. Just gonna add our own. So the description is just, let's call this loco. And then controller description, loco, loco. So now let's compile. Let's see if everything built. Some people have joined the chat. E. Clementine and Lauren Schmidt. Hello. Yep. Something's not happy. What was it? Oh, I forgot to. Did I forget to rename this? Yeah. So while that's building, I'll just give a quick update on what we're doing. I had written this blog post about how to do like a walking pair of robot pants. I'm converting that sample code right now into an animation node, which is basically a way of running animation code in Unreal on a background thread so that it's more performant because it doesn't sort of compete with like your game code on the main thread. So now that this is building, I can open up the engine. It's loading, but the loading screen is on another monitor, so you can't see it. Oops. But here we go. So now, I think what we want to do is I have characters/dev for like new characters that I'm developing. I'm gonna make a animation blueprint. We're gonna make it off of the loco skeleton. We'll call this AVP loco. So an animation blueprint is kind of like, it is to animations what like shaders are, right? It's like a little sub-program that runs your animation that's paired with the character, but it all happens off the game thread. So now we've added that new anim node loco. Oh, but I'm not seeing it. Oh, I wonder if it's context. Yeah, here we go. So loco's the new pose that we added. You see this is structured as a modifier, so it's going to modify a pose. We can pipe that out here, which is just converting it from component space to local space. That's why it wasn't popping up before. And then we're going to feed into this mesh space ref pose. So currently this isn't doing anything because I haven't actually implemented it yet. So it's returning false from isValid to evaluate, which means the pose is just getting fed straight from input to output at the moment. But this is good. This is like a gold spike. We've confirmed that we've added a new anim node to the engine. So I can save this. We can close that. Yeah. Now let's, yeah, we can X out of here. Now let's start actually moving over the sample code. So, the local pawn. So the pawn had all these different sort of configuration parameters, which I think this was all related to the root motion, which the animation isn't going to handle. But all of this stuff, how the character leans, how the hips bounce up and down, and what the size of the steps are, I think these are all important parameters that we need to copy over to our new guy here. And then, yeah, so this one here was the outputs to the anim instance that the sample code used, but we're just going to have this stuff directly. So then, okay, its movement stuff was like it had position, velocity, acceleration. And then there is target yaw, yaw speed, add a smooth lean. So yeah, I think this node here is going to need to grab a bunch of that stuff. So let's get some private parameters. Make sure this builds. Yeah, we're good. Okay. So then it had some hip state stuff. I think also in here we're going to want to copy down the position and the velocity. Well, you know what? The position, we're going to be able to just get that from the actor. And probably the velocity too. So we don't actually, do we need to sort? I don't know. We'll see. And then here we've got foot controller. So we have one of these for each foot. It has what the resting position of that foot is. It has what's current pin position, if it is pinned. And now references to loco pawn needs to be replaced by references to loco. Position. Where did those come from? Oh, I see. I don't think I actually need that. Well, we'll see when we get to that. Cool, so I think that's all the declarations that we need to copy over. So now let's actually copy over some code. We'll start with these foot controllers. Why is this unhappy? Ambiguous symbol, foot L. Oh, because I had these up here. We'll call it foot bone L, foot bone R. Excellent. So there's two more methods we need to implement. Nested type, so we need to fully qualify the name. Okay, we've got so much boilerplate, but so little code. Let's actually copy over the implementations now. So the way that this worked, oh, we have this step arc function, which I think is going to be important to copy over as well. So, namespace loco util. I think this I can just get from my movement utils. I only copied it into this file for the purpose of the blog to have everything in one file. So don't need any of this, don't need any of this, don't need any of this. Well, we do want to reset this, and we are going to want to init. So when we initialize, that's what we're going to do. let's initialize the bone references, which is, so how this works is hit bone.initialize, and that should take acquired bones, put bone L.initialize. We'll have to put bone R is valid to evaluate. We just want to say like return hit bone is valid to evaluate. And cool. So pre-update, I don't actually think we need a pre-update. I like barrel roll had one, but I'm thinking like, is this necessary? I think update internal is enough. So let's get rid of pre-update. So it has pre-update, we'll call that false. Pre-update here, we'll just do nothing. So now in update here, we should be able to get the delta time from the context. Cool beans. So now let's see everything that happens in the update. So in this sample code, first we did some camera stuff, don't care about that. Then we did some like stick handling, acceleration, update velocity, update position. We're not doing any of that. What we are going to do is just grab the actor from the context. So context.get, what is it? Get owner. There is a way. Random instance proxy get actor transform. Now what's the return type of this? Is it a reference? Let's find out. Yeah, it's a reference. So we have the transform. We're going to want the velocity as well. Not get scale mesh component, get actor. There we go. So now we have this transform has the position and the rotation of our character, and then this velocity has the velocity of our character. So unlike in this like sample code where we computed all that stuff, now we've just grabbed it ourselves. But we are going to want all of this code that uses that stuff. So normalize, okay, I call it velocity. There was a movement speed parameter in here as well that I got rid of, but I don't know why I pick here. Okay, and this is updating the character yaw. We don't need any of that. Normalized speed is used lower down though. Oh, this tracks the acceleration as well. What are we gonna do about that? This is pretty important for the lean. We could, so like option number one, do I track acceleration in enemy units? That could, we might just be aware of the fact that we're using enemy units and use that directly. So enemy units do all of their movement through the slide component. The slide component track acceleration, get position, get velocity, get rotation, get direction, get angular velocity, get up direction. Okay, it stores the position and the velocity, but it doesn't store the acceleration. So let's just store the acceleration ourselves on here. So we'll have new property, transient, blueprint, read only, and then when we slide with acceleration, we will just set the acceleration. So now in our little locomotion dicus here, we're going to also want to get acceleration. Oh my goodness. This is kind of like janky what I'm doing right now, but I just want to get it to work. Like component by class, use select component. So we're just going to tag this whole thing here, gather inputs. Okay. I'm thinking this smooth lean in my sample code was being applied directly to the actor. I think now it's going to need to be applied to the root bone. Let me confirm that my skeleton actually has a root bone. So for now we'll just say 0. Zero all this out for now. Do a quick build. I'm just going to open up the skeleton and check if the hip is the root of the character or if the root has a true root. I usually try and have a trajectory bone at the origin just so that I can layer root movement inside the animation. Multiply defined symbols. Are they in the same namespace? Yes, I called this loco util as well. So here we'll say node loco util. I promise you we're going to get past this boring part. We're going to cross this off our list and move on to the fun part soon. It's just a little bit more dumb stuff to go. Whoa, we're doing this for like half an hour. Welcome to programming. File turns as well, cute meow. Yeah, he's a pretty cute little guy. His name's the boy. we open up our animation blueprint, and then I just go to the skeleton. What have we got here? Oh, it is true. The hips are at the root. I wonder if there's a way for me to get like the true root bone, even though I didn't author one. Let's see. If I go here and I pick, okay, hips are hips, foot L is ankle L, foot R is R. You can see all those properties that we put on the anim node, Unreal just auto-populated them. So now I can actually go in here to, let's just like drop a breakpoint at is valid to evaluate. Hip bone, what value did you get? You got bone index 0. Okay, so you're the root. Nobody is more root than you. So what we're gonna have to do is when we're computing the transform for this hip bone, I wanted to just rotate like a bone at the root, but I didn't add a trajectory bone for that. I'll do that on my next revision. But for now, I'm basically gonna have to like translate the root to the origin, rotate it, translate it back out, right? And that's gonna get us, you know, pivoting the hips around like the sort of root of the character, not just around the hips, like floating position. A little bit annoying, but not the worst thing in the world. I can actually like hold off on that for now. We'll get to that later. But meantime, we can get rid of that breakpoint. Are we still in the, are we still? No, we got rid of it. Okay, this is evaluating. So, we'll close the engine down, go back to working on this stuff. Okay, so this loco util damp spraying, we now just have movement util damp. It's the same function. This is just my normal version of the function and not the one that I wrote for the blog. Hip offset, did we not bring that over? Where's that coming from? Oh yeah, that was these. Let me grab all these. So, whoop, I'm in the wrong file. Let's close a bunch of these unnecessary files that are confusing me. Great, we have loco pawn, and then we have anim node loco. Yeah, so here were these properties that it had. As you remember, we had ref position. So it's going to go through, it's going to evaluate all this stuff, it's going to guess a hip offset, it's going to guess the hip rotation, and then the feet are going to update. So let's copy over that foot code now. There is init, zoop. Then there's update. Okay, so both of these right off the bat want to get the actor transform. We're gonna do What? Why are you not letting me type? Writer. Okay, all typing has ceased. Something's gone wrong. I can't type in any program. I have no keyboard. What? Okay, well this sucks. Something's gone very wrong. Let me save all. If I cut out a rider, do I get my keyboard back? Why do I not have a keyboard? Why is my keyboard not doing anything? We're gonna do some technical troubleshooting here real quick. My keyboard has died on me. Really? It like looks like it has power. Let me stand by. Well, is it wired? It's wired and it's glowing, but the keys are not keying anything. I still have a mouse. Let me try. I'm gonna unplug it and plug it back in again. One sec. Okay, I've done the pro move of unplugging and plugging it back in again, and now it works. Thank you for your emotional support, little guy. Okay, here we go. M node logo util. So it's expecting to get the actor transform and the velocity just off of this loco object. So let's just, for now, just store those here. So transform, actor transform, effector velocity. Anyway, I didn't see you enter the chat, Final Turn. Hello, Final Turn. So, all the code compiles, right? Like I hit compile and it just all compiles. Nope, something is unhappy. Declaration of velocity hides class member. Yep. And in initialize, we probably want to do something similar. Okay. So, no, everything doesn't build yet. What is stick tilt? Update the hip offset. Oh, this is based on hip multi. Target speed, target duration. Okay, well, I don't. Yeah, we'll just call it 1 for now. This means that it's just always going to be going like this. So like this code was like in the sample code on my blog, it would only do this while you were tilting the stick, and then when you let go of the stick, it would stop. We'll figure that out later. There's a bunch of like inputs that this thing needs to be fed. I think like ultimately, like anybody who has a AnnoNode loco will probably just implement an interface that provides everything it needs, like the acceleration here, like the stick tilt here. I'll just give it a name. Cool. So now everything builds. It still won't do anything because we have not implemented the key function, which is evaluate skeletal control. But let's do that now. So what update did was compute these parameters: the position of the feet, how much to offset the hips, how much to rotate the hips, and whatchamacallit, how much to lean the characters. So now I'm going to come in here, I'm going to add a new header file that I've used elsewhere called animutil. There you go. And animutil has a bunch of fun functions, but like a nice key one is I have solve to bone here. So this is like a two-bone IK solver. So let's, first things first, all we're gonna do is have them like pick up and put down their feet in the right places. So let's get the, what is it? We've got foot bone L, right? So output.get pose.get component space transform f compact pose index, or actually I think it's just foot bone L dot get compact pose input. We'll just make a copy of this because we're going to be modifying it. And then here, let's say index of foot bone L is foot bone L dot get compact index. Index of knee bone L. And what we're going to want to do here is say output. There should be a thing in here. Is it pose? Somewhere in here, like, is it? I should be able to get parent indices. Where is it? I think it's actually anim instance proxy. Get required bones dot get. Parent bone index of index foot bone L. Boy, what a mouthful that is. Const auto index hip bone L. It's output.anim instance proxy get required bones get parent bone index idx knee bone L. So then this is foot bone L, foot, or this is going to be knee L, and we're going to get hip L, so these transforms are all the like incoming pose. So we want to like leave the position of the hip alone, but we want to rotate all of these into a new position. And that new position is foot position L, although I think that's in world space, right? Let's check. To world.transform position. Yes, that's in world space. So what we need to do is we need to convert that into component space. So target position L is going to be transform, or we have actor transform, inverse transform position, foot pose L, right? Now I'm going to say anim util 2-bone solver, and then 2-bone solver is, let's check. Oh, it's solve 2-bone actually is the name. Great, now we have these things. So we want the pointer to the transform to the root, that's ampersand hip L. We want ampersand knee L, ampersand foot L. We want the target position, which is target position L. And then there's some optional parameters, but we're ignoring those for now. That just have to do with the pull vector, like if we want to swing the knee. We're just going to say keep the knee pointed along the same plane as the incoming leg. The knee is a little bit bent in their rest pose, so we have like 3 points we can figure that plane out. And then down here, now we need to write these results back out. So to out those transforms, we're going to set the number to 3. Eventually it'll be 7. It's just 3 for now. But then outbone transforms index. We got to do this parents before children. Outbone transforms 0. Dot bone index is index hip bone L. Transform equals hip L. We have knee L, foot L, index knee L, index hip bone L. Cool. So now what should be happening is the foot should just be going up and down. I'm going to cheat real quickly here and just call the normalized speed 1. This will cause the foot to just be going up and down in the, like, even when it's standing still in the editor preview, in the animation preview. What is this? Get compact pose index. Oh, this takes required bones. I think it's actually just I shouldn't need to do this, but whatever. Foot L. Here, let's call this transform foot L, transform knee L, transform hip L. So if this is all working correctly, that left leg should just be like going up and down in the animation preview. Uh-oh. Already something terrible has happened. Oh. Congratulations, I made a boneheaded C++ mistake. I walked one past the end of the array. No, he's still unhappy. Why are you still unhappy? Index. Very unhappy happened. Wait. Why is the debugger not letting me actually look at these values? index equals 5. I is 2. There's 3 of them. What's it unhappy about? This can't be at the right. There's 3, and I'm indexing 2. Apparently, this is a perfectly okay operation. But range check is not happy about it. Let's reread this code. Did I do something boneheaded? Welcome to C++, folks. Zero, zero, 1, 1, 2, 2. Set num. What if I say set num? Just set num 3. I could also say outbone transforms in place idx hitbonel tx hitbel. Like just add them like this. Or what if I say outbone transforms reset? Just do this in the dumbest possible way. Crash again? No, now it's okay. And check that out. Just like I said, foot's going up and down, right? So the code is running, the foot's going up and down. So we've got the left foot going. Let's just get the right foot going. So it's gonna be a whole bunch of this garbage again. Let's do it. R, 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 R. A whole lot of L's gotta get turned into R's. And then, additionally, I'm gonna, at the bottom here, like, you're supposed to insert these in index order. So actually, this, yeah, I don't know. I'm just gonna say sort. This is so stupid. Bear with me. I'm just going to sort them. I shouldn't need to do this. I should be able to just check, like, should I add the left foot or the right foot first, but this is just the easiest way to do it. So now we should be able to hot recompile because we didn't change the memory layout. Yeah, there we go. So now we got both feet going up and down. Probably have them doing more than they're doing right now, but let's not worry about that. There's also like a bunch of other stuff in my hindbrain that I think I need to handle, but let's just leave it alone for now. So the last thing we need to do is for the hips, I need to say output transforms. How were the hips evaluated in the original one? It was here. Let's actually just like get the hips right first. So const f transform hips equals output.pose.get component space transform, and then hipbone.get compact pose input output.get an instance proxy get required bones. Let's just take this and just say bones. We don't need to say this over and over again. Just say bones, bones. Same here. You can just take bones, bones. Let's get some redundancy out of this. And then actually, let's just like group all this by type, just so that the code's more regular. We're like here, we're gonna get, here we get our target positions. And then here we're getting all our transforms. Then we do all our IK, then we do all the rest of this. So with hips, what we're going to want to do is actually, I'll call this just for consistency, tx hips. So we're going to say hips. What do we have? We have their offset and their rotation. So hips dot set. We'll just say tx hips equals tx hips times transforms hip offset. Actually, we want to move it to the left-hand side. I always forget. These F transform objects do matrix multiplies transposed. It does them in the reverse order than like quaternions and matrices and like the math textbook order. It's insane. But I'm thinking about this, and I think what we actually need to do is tx hip. Let's actually get this const f transform ampersand tx hips orig, and we copy the original because, like, if you think about this, we're moving and rotating the hips, and that means that these hip transforms have to change as well. So we could say tx. Like, actually, I kind of just want the whole chain to be updated. This is so stupid. Okay, so the math that we're thinking about here is I'm like tempted to like actually move some of this code out of the anim node, but I've already gone too deep here. So let's just do this, right? Like, we want, like, you have a thing which is like my transform is equal to the hip transform times my relative transform. And then this is my like old new world transform is equal to new hip tx times relative tx. So we have the old world transform in this. So we can determine that the relative transform is just the old hip transform inverted times the old world transform. That's just equal to the relative transform, because this old world transform on the left will cancel out. So then we can plug this in to here and get new world tx is equal to new hip tx times the old hip transform inverted times the old world transform. So we're just going to call this the converter, right? So old hips. Now remember, like I just said, the multiply order is like, ooh, backwards. So it's going to be the tx hip orig dot inverse times new hip times tx hip like this. And we can go through all of these datases. Actually, I think there's like some helper functions in Unreal that'll make this easier. Let me just think, like tx foot L is equal to like tx foot L dot get relative transform to tx hips orig times tx hips, right? I think this is actually the right way to do it. I think this is just like a little bit cheaper than what I was doing before. Cool. So now let's hot recompile and just see how this looks. Oh, look at that. Look how wrong that is. Look how unbelievably bad. What is the definition of get relative transform? Functions to get the transform and return the transform that can be concatenated. Get relative. Let's try the reverse one before I go too far down this rabbit hole of trying to like understand what this is supposed to be. Okay, well that one's unbelievably wrong. Okay, so here we have them going up and down. Hips are like basically doing nothing. What am I doing wrong here? Hip, knee, foot, knee, hip. Something wild happening there. This is fun. So I take the foot, I get the foot relative to the original hips, and then I multiply it by the new hips. So like, I don't know, I don't think this should be reversed, but let's see what happens. This is like the way I would expect it to be for matrices, but these aren't matrices. So this is gonna look wrong. Yeah, this is still hella wrong. Okay, what if I just got all these bits backwards? Still crazy wrong. Hate that. Let's just drop a breakpoint right here and see what are these values. So pitch yaw roll 0, 0, 0. Hip offset 0. Okay, wait, these should be TX hips. The TX hip ridge should be like the same, right? I just like pass in like hips, ankle L, ankle R. Index hips is hip bone. Index hips gets passed into this get component space transform. These are all component space, right? These are all transforms in the same coordinate space. Hips is a copy of TX hips or ridge. I apply a local transform, which is like basically nothing. And then what I'm doing here is I'm just like, yeah, this should be get relative transform returns this times other dot inverse. This should absolutely, as far as I can tell, this code is correct. This is driving me crazy that I'm seeing the wrong thing. Yeah, let's just, looking okay, love it, go back like this, now you're all messed up again. Okay, well what if we did all these as like, just like literally the math I was going to do before. Let's just replace this with so we're starting in world space, then we're going to relative space, then we're going back to world space. Still messed up. These should cancel out. That should be like nothing. What is delta here? So the translation is a whole crazy number. I wonder if it's actually because these have like an insane scale on them. 100, 100, oh my goodness, okay. Okay. That's the deal. So, this is like a dumb Unreal thing, but sometimes when you scale a character on import, it just scales all the individual bones inside the character. So all these bones have stupid scales on them. So what we want to do is, what's the best way to do this? We want to like ignore the scale on all of these. And then we want to put the scale back in later. We're just going to hack it for now. I can't believe I have to do this. This does not make for great streaming content. But like, I can like come in here and I can just show you like all of these bones have a scale of 100 on them. Or at least the, oh, just the hip bones? Well, the hip bone has a scale of 100 on it, but then all these bones, right? So, oh my, yeah, this is, it's so stupid. I hate that Unreal does this. But we can account for it, right? We can say like, here, we're gonna go in here and say F transform without scale. And then when we're getting all of these, right, we can just say without scale. And let's just at the top here, just say using namespace anim node logo utils, so we don't have to qualify all these. So we're going to get all these without scale. And then we're going to have another stupid function that is with scale. And then when we write these transforms out, we'll put the scale back in. I think all these guys having that 100 scale was like really messing this stuff up. Okay, so now we see the hips are bouncing, doop-a-doop-a-doop-a-doop-a-doop, but we're not actually writing out the hip bone yet, so let's also do that. So IDX hips with scale TX hips. Great, look at that. We got the translation and rotation of the hips. We got the legs. I'm sorry that everybody had to watch me probably do a bunch of stuff that you didn't understand. A lot of this is hacking. But yeah, just trust me when I say it's all for dumb reasons. If anyone has any questions about it, just sound off in the chat or DM me wherever. But great, now we've got this running. So let me go back to that hack where I just set the normalized speed to 1. Let's set that back to the velocity now. That should cause this to like, whoa, what happened there? Something unfortunate has happened. I don't know what it is. Oh, I actually just introduced a typo while I was consolidating some code. There we go. Okay. I don't know why he's still doing like a little bit of a crab walk. It should be 0, right? Let's see. So here it's saying the normalized speed. Oh, was this? Okay, you know what? Here. We're going to... I've been building without debug symbols like a dag fool. So let's get out of our debugger. Let's change to the debug game profile. I should be able to debug these easier. But anyway, I'm going to say at least at this point, we have done step 104. We have converted that sample code into the anim node, and we saw it doing the steps, not in the scene, but like in the animation tool. So the next thing is we want to add a new enemy type. Once I do this, just like quick smoke check. Okay, so here we go. I don't know why it's still walking really slowly. Let's see. Let's put a breakpoint here. Normalized speed is 0, yeah. So the lean is basically just going to be, that's just the identity. Okay, oh, the play rate, it's never below 0. So he's always going at least quarter stepping. But that target hit multi is always 1, right? So let's just change that target hit multi real quick to be like normalized speed is greater than 5%. Actually, let's just plug in the normalized speed. Oof. So now if I look at this animation blueprint, it should just be standing still. And there it is, standing still. We've gotten rid of all the like gobbledygook. So let's move on to step 2, which is adding a new enemy type. I have a single file here called enemy unit dev, which is like when I'm just experimenting with new enemy types, I don't go through all the rigmarole of like adding a bunch of new files for it. I just shove everything into this one sort of like garbage file, and then when I actually like things, I factor them out into their own things. But let's make a new type, which is enemy dev, and we're going to call this walker test. It's going to be an enemy unit for now. Constructor, natural no, and then yeah, let's just handle these events. What did I do? I don't know what I did. So I've done a bunch of different streams before about how I do AI for my enemies, but I'll just explain it real quick. Each enemy has a state machine. It's defined by these like enums, where you have like an identifier for each state. Sometimes I create ranges in the enum in case I want to check if you're in like a range of states. Oh, the boy has left. Let me move the camera and update the label. Hey, it's my face. I've been here all the time. Camera label. Cameron. Cat not detected. Can I center myself? Okay. So yeah, you can see like you'll have Wander, he's just waiting. Wander, he's like moving to a new waypoint, and then Aggro, he's like moving evasively. And then I have these handle event functions that I override, in which I combine the event with the state to create like sort of like combined IDs, like sort of these events, right? A state event tuple, like, oh, and then I like switch on that to basically do like sort of lightweight pattern matching. So it's like, oh, when I enter the spawn state, or when I update the spawn state, or when I update the wander weight, And at any time in this handle like event method, if I just return like a non-zero state ID, then it like will handle that as a state transition and then rerun the event with that new state. This is a very sort of pithy and easy way to write AI. I love it. It's like extremely fast. It's extremely easy to iterate on. It drives me crazy when I have to do stuff in like janky ways instead. So let's go down here. I see Norand has joined the chat. Hello, Norand. Just to give a brief update on where we're at, I spent an hour, more than an hour, doing some boring code refactoring. That's a lot of game development. And now we're adding a new enemy type for this like pair of robot legs that we're going to have walking around in our city. So in the constructor, we want to say that we are adding a why does it keep bouncing around like that? There we go. Why was the cursor up there? Ridiculous. So we're going to say that these walkers oh, that's not right. Cool. So we've said like, hey, the root of this character is a skeletal mesh. We'll assign it to the robot pants in the editor. And then here, we want to have a switch on event.makeSwitch with the state. We're going to say like default, don't do anything. Case, enemy event. If we spawn, enter, where is it? Yeah. So this is like the initial state the game puts us in. I'm also going to say like when we enter the spawn state and when we update the spawn state, we're basically just checking that we have. Yeah, I think like no matter what, like normally I do some like initial like figure out my initial state, like was I dynamically spawned or was I loaded with a level or was I spawned with a special spawner that wants me to do something different. So that's why I usually have like a stub spawn state. But in this case, no matter what, I just want to go to wander move as my initial state. But if we wanted to handle doing something different in my spawn, we could do it here. So in case enemy event state, or it's just wander move enter. Nope, my macro put state on there. I don't need that. We'll just leave a stub in here for now. And I'm gonna add a. Normally I add a special spawner for each of my enemy types, but yeah, here. Okay, yeah, I'll do that too. So let's make a walker dev spawner. This is going to be a very simple spawner. We are basically just going to say like, hey, we're going to spawn one of these guys, and we are going to spawn it at the transform of the spawner. And let's just basically in here say like if spawner is not equal. So basically, if one of these is just placed in the level, it's just going to sit in an inert state. I don't know what to do with somebody like that, but if you were spawned by a spawner, then we're going to enter your wander move state. And that's really just because usually you get your navigation information from the spawner, and you like kind of need that to plan movement. So anyway, this is all looking pretty good. Let's jump in and set up the spawner. Oop. Oh yeah, always got to have generated body. By the way, my spawners, like the reason I had to like override this and say I want one at the spawner is because you can do a spawner that spawns like 100 guys in a sphere, and maybe they just have random positions, stuff like that. So now let's go to our city map. If you haven't seen it, it's like, hey, it's a big city. There's some spaceships up there. There's some sewers underground. And this was the thing I was working on earlier this week. It was like a, oh, where did it go? There it is. What's this cool thing? Oh no, it spawns a bunch of enemies. So we're gonna come in here. We're gonna make a new blueprint class, and it's walker spawner. So this is VP dev walker spawner. Final turn says tea party. Yeah, I kind of mentioned this on stream and in Twitter, but like I was just using this Utah teapot for that enemy as like a placeholder because it makes it really easy to tell the up direction, and if you're looking at the front or the back of the object, or if you're looking at the side of the object, you know, is it looking to the left or the right? Yeah, so here's our walker spawner. There's nothing exciting here, and then we want to have another blueprint for our walker. BP dev walker test. So this one we gave it a skeletal mesh. For that we want to use the robot pants. And then for the animation class we want to do ABP loco. There we go. Wait, which one is it? I guess it's the same. There we go. That is the animation asset that we like refactored and authored in the first part of this video. And now go back to our spawner here, and I'm actually going to give this a skeletal mesh. I'm going to put the same footsies on it. Let's say no collision. I'm going to say hidden in game. And I'm also going to say editor only. Boop. So this is basically just when I place the spawner into the world, and here we'll place one in a convenient, what's a convenient place to put something that's out of the way? I guess over here by the beach. So when I place this spawner, you can see it's visualized like, hey, I'm going to do one of these guys. But if I like press G to like hide all the level editor visualizations, it goes away. That's just like a prop for like as I'm level editing. And then crucially, in the spawner configuration, the enemy type that it's spawning is the walker test. Boop. And then like let's give this, you assign loot on the spawner. So let's get here, we'll say that you're gonna spawn money. You're going to spawn 3 monies, and this enemy's destroyed. So now, all's good. We can come in here, we can hit play, and look how terrible that is. What's happening? I guess the like feet are like at 0, 0, 0, and it's like reaching all the way back there. We really got to fix that. This character, something bad news bears is happening. So where are these get initialized? 2. 2 world. Rest position is just the ref position from this. I wonder. Save and come out. Let me. Okay, I was just quick testing that it wasn't like a serialization issue. So these guys are clearly solving an IK target that's like way over there. So like let's go back to this and like look at everything we were doing. So here's update internal, where we got the actor transform, we got the velocity. If I hit play, there's one there. I can like drop a breakpoint here. We can see like actor transform. Yeah, it's not rotated at all, but it is at this position. It's about 1 meter in the air and like offset. That's all correct. So then let's sort of step through the code until we get to the foot update. He's like, okay, we're gonna get the 2 world. We get our position, which is 0, -30, 0. And offset position plus equals z equals 0. 2 world that transform position, rest position, position plus equals that, position.z. If pinned, otherwise, position equals, oh, 2 world dot inverse transform position. The position was always in local coordinates. So I actually made a mistake in my code. Okay, we can X out of here. I made a mistake in my evaluation code when I don't need these target positions at all. I can just use them directly because they were already in coordinate space, or in component space. So now I go like this, boom, we've got legs. So that, look how much more rapidly we're moving. We've added a new enemy type, X. We're halfway done with the stream here at almost 2 hours. I honestly thought that this initial part was only going to take 30 minutes, but you know, that's how it goes sometimes. So we want to have it moving around. The first thing for moving is if we open up our character here, this is because this descends from the enemy type, it has a number of pre-added components, right? So it has the aggro component, which is like its AI sensor that says like, can it see the player? Is it aware of the player? Is it responding to the player? Or is it just wandering around? So this is kind of like its view, right? This is a health component, which tracks both like how much damage you've taken and how much heat you have, like if you're overheating or not. And then there's the slide component here. And the slide component, crucially, is the dingus that like handles movement, right? So it's like a shape. You can see currently the shape is a sphere, and as you move, I sweep the shape through the environment and then make sure that like the shape itself doesn't overlap the environment. So that instead of going through a wall, you crash into the wall. Obviously, this shape is not matching the legs, so let's fix that right now. Let's take the radius down. Let's give it like a little bit of a, make it into more of a capsule rather than a sphere. And then let's give it a Z offset 75. That is not enough. Wait. What is this supposed to be? Okay, that's how it is. So if I take this to 125, this should just match it, 125. That's how I did it. Smarter than I thought I was. Great, so let's take the radius up a bit so that's a little more generous. Great, now we've got a more reasonable slide shape. So let's begin actually implementing that like wander move thing. So let me check out my slide component real quick and see if I actually implemented like, so I have all these slide methods like, oh, you can slide with velocity, you can slide with acceleration, you can slide to a position, but like I think all of these are like built, I think none of these account for like gravity or being on the ground. So that's actually something, I'm not going to worry about that right now, but probably off stream I'll do a bunch of boring coding to add that. But for now, we're just going to slide around on the ground, or we're just going to like slide around to positions. So here's what we'll do. Let's go to our AI. So let's give our guy a timestamp parameter called deadline. And when we enter the move state, we're going to set the deadline to, and actually we're going to start with its wander weight. We're going to wait for anywhere from like 1 to 2 seconds. And then when we're in our update, we're going to say if that deadline is in the past, congratulations, you're in the move state now. So now let's say when wander move enter, we're going to need to pick a, we're going to save all this stuff and X out. When we're in the wander move, when we enter that, we're going to want to pick a target position, as well as, I guess, a like target rotation. And so the target position, we did confirm up here that we only like actually enter our like wander state if we have a spawner. So we know we respond by a spawner, so we can just like get the spawner's location, and we can add some like random offset inside of it, right? So let's just get a unit, let's get a random UV. Where did I put this? Is it using util? No, it was in fact util. Random vector in unit circle. And we'll do like a 10-meter radius. This is an F vector 2D. Oops. And we only want to offset UV dot X, UV dot Y. We only want to offset, you know, in the XY plane, the horizontal plane. We don't want any vertical offset. And then, like, let's see, like, what's the distance to that target? So const F vector distance equals target position. So that's going to be like the distance from get position to the target position. Let's say our speed is 500 units per second. This is in, it sounds like a huge number. It's centimeters, right? So it's only 5 meters per second. 5 like checkerboard squares. And so like the approximate time that it should take is the distance divided by the speed. That's meters divided by meters per second is seconds. So then we can say the deadline for this state is just going to be the approximate time. I'm writing bad code. It's confusing writer. And then got break. And event. Wander move update. So we're actually updating the wander move. We're going to say that, what are we going to say? If deadline is in the past, return state wander wait. Otherwise, we're going to say, actually, when we enter wander wait, or actually, when we enter our first state here, let's set the target position to the current position. Now let's add a post update hook like my other character I was making has. Boop, boop, boop. So I can either update the movement directly in the AI state, or I can have the AI state basically just set a hint and then have another function resolve that hint. In order to let my like update system know that that's what we're doing, we have to say p this as post tick. This is just a optimization so that it doesn't call unnecessary virtual functions. It's always good to call super functions when you can. And so here we're just going to say that try damp and slide to position. Our target position is target pos. And we're going to say like if state equals state spawn, just early out. Actually, we can just not turn on our post tick unless we exit the spawn state. Target position, max speed, I think it's typed in 500 up there. We'll say that it takes you a half second to speed up. And then I have like a target rotation here, yeah. So here we'll set target rot to get rot. And then when we pick a target position, we'll just say target rot is from ZX after, and then the direction we want to look is target position minus my current position. So then here we can just say slide component ref pose damp rotation target rot. We'll say the same 5 seconds. This is not like some complicated movement logic. This will, when I do like the real version, this will be better. But right now I'm just basically, I have a target position, I've attached a spring between the character's actual position and the target position, and then I'm having the spring pull the character around. And then because I'm doing it through the slide component, it will resolve any collisions automatically. So now, here I'm just gonna run in no clip mode. There we go. You can see the animation code is running. It's actually quite bad. I don't like that animation code. Why is he so tall? I think I did something broken in the animation. I need to lower those hips down. Loco. Hip offset. What if I said the hip offset was like -25? There's like a lot of bad stuff happening here, I think. Why is the target position going up and down? Okay, apparently I've got a lot more. My refactoring was not as good as I thought it was. And this dingus is not solving things correctly. Well, I've got this hip bias. Is that the one I was thinking of? Yeah. Something's gone very wrong in the state of Denmark with this IK solver. Let's look back in our anim node. How does this work? We get all the indices, we get all the original transforms, we update the hips with the rotation and the offset, then we update all these transforms, then we update all these to match these positions, and then we write all these transforms back out. Hip L, knee L, bone L, hip R, knee R. Yeah, all these are right. It's just something unfortunate is happening. What if I never... Let's just like not do any of the hip stuff. Just have the like legs mechanically move. Does that kind of look right? Kind of looks right, but it's also very wrong. Like, why aren't the feet getting picked up? Really? What's happening here? Position equals inverse transform. I did some stuff here, huh? I wonder why, because if we look back at this almost identical code running in the sample scene that I developed it, I guess they don't pick their feet up that much. I mean, it does look basically okay. Do I just need to come in here and like give this a bigger step height? These feet are not picking up at all. What is happening? Huh. Hip offset, hip rotation. Height, where from the pinned position to inverse of this one, this position.c plus equals step height times hip multi. Ooh, this hip multi is probably tiny, right? I just set that to the normalized speed. Let's go back to this thing I was doing before. Like normalized speed is greater than 0.01. I think this might be the issue. This like hack that I put in. No, I don't think that's it. What is this dingus doing? Yeah, let's put the hip offset back in. I don't understand why the targets are going up and down with the hips. Knee, foot, knee, foot. What's the deal? This should all be in component space, right? Knee, hip. I didn't have any like just stupid typos in here. Bones, foot, knee, bones, foot, knee, foot L, foot R. Huh. I'm at a loss. This two-bone solver, like this is making the legs pop up and down, but then this two-bone solver should make sure that the foot is at the right place. Let me just like do a quick debug draw where I'm like draw debug point. The world is let's do this in update instead. Position should be actor transformed of transform position, and it's a foot position L. Size, let's make it 10 pixels, yellow. Don't need any other parameters. And we'll do R. These in an F1 so I know they're together and make it easy to disable them. So now if I go look at those, where those are like way down. Those feet are way down at the bottom. Those legs are getting stretched out. Okay, that's the problem. How are those getting positioned? What are you complaining about? Oh, okay. Ugh. Well, it sounds like we've got some stuff to debug, but let's just do a thing real quick where I'm like, I suppose is, let's see, L is -30 is left. Those positions are still hella low. Don't know what's up with that. The actor transform is right there, so it should be setting their z = 0 pose. It is zeroing their position here. If we want pin position equals position, else pinned position is inverse transform position, pinned position. Isn't it pinned in world space? Yeah, transform position. World. Oh, I see. I see. I think that. Yes, I think in my okay, this is so stupid. I think in my sample scene, I was just assuming you were walking on the z = 0 plane and not bothering with like, yeah, here we go. We weren't really bothering with like what would you call it? Like actually raycasting for collision. So that's what was messing stuff up. But now we can see everything's basically pretty good. I mean, it's a little extra jaunty because I exaggerated the steps, but if we go back to our configuration here, mess with those values a bit, we should get like something a bit more reasonable. So how fast is this guy currently moving relative to the player? Let's get the player out in here. Okay. Seems pretty good. I think actually probably it'll be better if I like scale it up. I want to scale it up anyway because I want like the enemies to be a lot bigger than you so that they're easier to shoot. Whoop. But like I think this is like a pretty good baseline. Probably once I scale this character, a lot of my math is going to get unhappy, because then the actor transform is going to have scale in it, but that's going to be pretty easy to account for. But anyway, I think like we've now finished step 3, we've got wandering movement code, so I think the last thing now is to add just an aggro streaming mode. So let's just go into our character here. Nope, that's the spawner. We want to go into the actual test character, and they have an aggro component. Let's say that like you have a sphere to enter aggro, and it's if you're within 25 meters, and then to exit aggro, it's also a sphere, and the distance is like 50 meters. And let's actually make this like actually like a cone, and let's just say 120. So you gotta like basically be, so the way this aggro works, you have to like basically be generously, but basically in front of this character, and then and we can actually zip that back a little bit so that, you know, it notices you even if you're like close right behind it. And then you need to be pretty far away for, I don't know if you can see it over the stream, but for this thinner sphere, like you have to be more than 50 away before it like loses track of you. So now I'm just gonna do like a really sort of quick dumb thing, just to see it working. We're gonna say if aggro component is aggro, we're gonna say plot temp rot equals target rot, and then if you're aggro, damp rot is from ZX, and then it's aggro component last aggro position minus get position. So it's just gonna, all I'm doing right now is if you're aggro, it'll face you rather than facing their current target direction. So should be enough to just walk out here, and then like once he gets in front of me, he's like always facing me. Look at that. Back pedals. It's pretty nice that the locomotion code just sort of handled that like on its own. So, and then let's just add a really quick test here. If event, you know, let's see, bool b enter aggro equals event dot is update, and aggro component is aggro, and state is state in range wander start comma range wander end. If we want to enter aggro, then we're going to enter aggro. What did I call the aggro state? State aggro moving. Otherwise, bool b exit aggro. I really should make like a pithier way to do this because it's something I write a lot. Start range aggro end. If we exit aggro, then just return to state wander. These can both be constant. I try and make things as constant as possible. So now we can add a new case down here. Case enemy event aggro moving update. And for this one, we're just going to say like pawn position is aggro component, get last aggro position, and we're going to just continuously update the target position to be the pawn position plus my position minus the pawn position, get safe normal. And we actually only want the horizontal component of that. And we're gonna separate by like 10 meters. That's 10 centimeters. There we go. Now we're 10 meters. So now, instead of like, oh, Honorary Concocts says, hey, sorry for bothering you. I want to offer promotion. Ugh, get out of here. Gross, gross, gross. Cool. Somebody just tried to spam our chat, and I just blocked them. Okay, sorry for that little break. Yeah. So now the target position should be continuously updating. So like, kind of like you should like basically be trying to like. Okay, something quite bad has happened. What is it? Palm position plus this is the target position. And then we're trying to slide to the target position. What did I do? How did I break something? There we go. Now he's like, here, let's take that distance down from 10 meters. Let's just say 5 meters. Yeah. So yeah, now you see when it's aggro, it's just kind of like maintaining this distance from me. I can kind of push it back, or I can go this way and it kind of starts chasing me. This is pretty fun. And then when you go back against that, because it has the slider, it doesn't like clip the wall or anything. I can't actually blow him up though, because he doesn't have any collision, so let's actually give him a hitbox, right? I think that's like a nice way to finish the stream, because then everyone can just see him like blown up. So we'll just, I guess I'm just gonna add a capsule. We're gonna call this pawn collision. Bring it up here. There we go. I think this material that it's using, this, what is MI logo? Okay, it is subtyping, yeah, one of my master materials. So it should have the damage, yeah, it has damage flash on it, great. And then we'll just add a quick event. I only use the blueprint scripting for VFX for the most part, but enemy killed, we're just gonna like spawn an explosion. Spawn emitter at location, position, and that emitter, what's a cool explosion? Look at particle systems. What is this one? It's so ridiculous. Let's do it. Maybe I'll make it big, I don't know. So now, I should be able to shoot it. That ridiculous. Okay, this was too big. 111. Also, we probably want to run it faster. Custom time dilation. Oop. Set custom time dilation. Maybe run that twice as fast. This is so dumb looking. And then we'll also shake and flash the camera just for good measure. Okay, actually we don't want to use get position. We want to use get actor location. No. Get actor location. Why is that not the one that gets highlighted when it's exactly what I'm typing? Let's double the speed of this one again. It was still a bit slow. It's kind of ridiculous. I don't actually want to use this explosion, but I think it's kind of funny. And then just, I don't know, just to see, can I like just scale this dingus up? If I did that, would the world care? Or would the animation code get like totally broken, or what would happen? Animation code's relatively okay. I mean, I do think like it's getting a little too jaunty for how it's moving, but yeah, we definitely want to multiply this by get actor, scale 3D. Cool. So I think that's where we're going to leave it on the stream for today. Imagine though, if you will, once this guy's got like a big gun, it'll be just like a big mech. I do think, like I was saying, it probably needs a third leg out the back to act as a balancing leg. Okay, it's so ridiculous how jaunty it is. I actually want to fix that. Probably what we want to do is, I guess for now I'll just scale it back down. But really, I want the animation system to be aware that when it's twice as big, you should also like double all the speeds. Cool. So yeah, pushing him around. Don't know what that was all about. That's an interesting little thing. When he's like rotating too quickly, he gets kind of weird. Interesting. Awesome. Thanks for watching. This is kind of a fun little Sunday lazy stream. I want to do more like off-schedule streams. Like we'll definitely have one every Friday around lunchtime, but like I want to do one or two other ones during the week, just to give people more opportunities to ask questions and stuff. This is Nightshift Galaxy. It's a game that I'm currently prepping to put into early access on Steam. I'm hoping to have that this fall. Yeah, you can follow the Twitch stream. You can find us on YouTube, where I have an archive of everything after the VOD expires. I also just post some other stuff that I'm working on that doesn't make it onto the stream, just to my Twitter account, which is @ZooLupus. And if you want to get in touch outside of my like live broadcast times, if you go to my any of our, just search Nightshift Galaxy, you'll find our Twitter and stuff. Or you can look in the description of the Twitch thing here. You'll find a link to the Discord. There's like an ongoing AMA thread if you just want to like ask about anything, or just follow along for any updates that are off stream. So cool. Thanks for stopping by. Bye.